Okay, this is on special right triangles. These are some special cases of right triangles and talking about the relationship between the sides of special right triangles. And the two special cases we're going to look at are 45, 45, 90. So we're going to look at 45, 45, 90 right triangles. And we're going to look at 30, 60, 90 right triangles. Those are the two special cases. Okay, the first one I'm going to look at is 45, 45, 90 right triangles. Okay, and draw it so it looks like a right angle here. And this one would be the same as this one. They're both 45. 45, 45, 90 right triangles. There is a special relationship between the sides and the hypotenuse of every 45, 45. Because these two angles are 45, then these two sides have to be the same. Standard labels in trig are 1, 1, radical 2 for a 45, 45, 90. But in geometry, they're going to change, and basically they're saying that to get from this side to this hypotenuse, you multiply by radical 2. Okay, so if I gave you, in general, standard labels would be x, x, and then this one would be x radical 2. Okay. So if I said I want to go, let's say I give you this leg and I want to go to the hypotenuse, I multiply by radical 2. If I give you the x radical 2 and I want to go to the leg, what do I have to divide by? What do I have to divide by? To get from here to here, I have to divide by radical 2, right? So you're either multiplying by radical 2 or you're dividing by radical 2. Okay? They're the same. They have to be the same. Okay? So they will give you problems like this, and they will just say find x. Okay? And don't make these hard. Okay? You look at the picture. Okay? And let's say this is 45, this is 45. So if I gave you this side was 5 and this side was 5, what's the hypotenuse?
5.
And you do it by side. And that's actually what they were asking you to solve for. Solve for x. Okay? Don't make it hard. Okay, if they turn it around, and let's say I gave you this is x, and let's say I give you this is 10. Okay, how do you get from the hypotenuse to one of the sides? You divide by. So now what we just talked about, you got to take 10 divided by radical 2. You cannot leave a radical down in the denominator. Multiply by radical 2 over radical 2. You got to do that in the top and the bottom because you're actually multiplying by 1. So you'd have 10 radical 2 and radical 2 over times radical 2. 2. Now you can reduce this 2 with this 10. You can't reduce it with the 2 underneath the radical, so 5 radical 2. Okay? So both sides would be 5 radical 2 and 5 radical 2. Okay? So if you know, basically let's sum this up. If you know the leg and you want to know the hypotenuse, multiply by radical 2. If you know the hypotenuse and you want to go to the leg, you divide by radical 2. Good enough on that part? Okay. Yeah. Mm-hmm. Then you divide by, like if I gave you if this was 45, 45, 90, if I told you this was 7, then what's this side? And what's this? 7 radical 2. Okay? If I said this was let's say 20 and this was 45, 45, 90. 45, 45, 90. So what are you going to have to divide by? Yeah, so you divide by radical 2. So you divide by radical 2, which means you got to multiply by, so you'd have 20 radical 2 over 2, which would be 10 radical 2. So you're either multiplying by radical 2 if they want to know the hypotenuse, or you're dividing by radical 2 if you want to know the leg. There's only two choices. Okay? Okay, that's 45, 45, 90. Put a little separator. The other special case is a 30, 60, 90. 30, 60, 90, right triangles. Okay, and there's a special relationship between every 30, 60, 90 right triangle. Standard labels when you get to trig. Standard labels, the side opposite, the 30. Okay, watch up here a minute. The standard labels in trig, the side opposite the 30 is 1. The hypotenuse is twice that shorter leg. How do you know which one's the shorter leg? It has to be small. It has to be opposite the smallest angle. Which one's the smallest angle? 30. Okay, the hypotenuse is twice that shorter leg. The longer leg, and that's the one opposite the 60, is radical 3 times that shorter leg. So radical 3 times 1 is just radical 3. Okay, so they are in a relationship. Okay, now, the longer leg is radical 3 times the shorter leg. Okay? Okay, now, here's what they're going to do in geometry. In geometry, they're just going to say, put a scale factor in there, okay, as an example. So, if this was a 30, 60, 90, and let's say I gave you this was 4. If I gave you the shorter side, the hypotenuse is twice that shorter side. So it's 8. The longer leg is radical 3 times that shorter side. Yeah, and they're going to put the, you can write it, but I would put the 4 in front. Okay? Now let's turn it around. Let me give you some others. Let's say this is 30, 60, 90. And let's say I gave you this hypotenuse was 12. Now, don't go to the longer leg. Go from the hypotenuse to the shorter leg, half of it, which would be 6, and then 6 radical 3. Okay? Okay? So 30, 60, 90. Let's say this was 7. Let's just go 7. Let's say I gave you the longer leg. It was 7. Okay, go back up here for a minute. How would I get from radical 3x? Divide by radical 3. So you got to take 7 divided by radical 3. I can't leave it like that. So I'm going to multiply by, radical 3 over radical 3. So I get 7 radical 3 over 3. And that is this side, the shorter leg. 7 radical 3 over 3. The hypotenuse is twice that. When you multiply by 2, multiply by 2 over 1. So is that changing the denominator? No. So it's just going to be 14 radical 3 over 3. All it's going to do is change this number, right? Because you're multiplying by 2 over 1. When you do that, you're taking, right? You're not changing that bottom at all, right? Okay. Now I'm gonna change this. Everybody done with that one? Okay. Okay, I gave you the hypotenuse. How do you get from the hypotenuse to the shorter leg? Divide by 2. So that would just be 15 halves. Do I have to change that to a decimal? No. How do I get from the shorter leg to the longer leg? multiply by radical 3. So 15 radical 3 over 2. Was that hard? Better that way than all the decimals. Much quicker this way. Okay? Okay. I'm just changing things up a little bit. Hypotenuse would be 12. Longer leg would be 6 radical 3. Now, let's say I'm doing this on a test, and I want to know I'm right. For a right triangle, what's true about every right triangle? Which theorem? Good old Pythagoras. So if I wanted to check this, I would say 6 squared plus 6 radical 3 squared equals 12 squared. So 6 squared is 36. When you square this, you square the number in front. 6 squared would be 36. Radical 3 squared would be 3. 36 times 3. 108, right? Does that add together to 144? Yeah. So you should be able to check all of these by Pythagorean theorem. Okay? Okay, let's do one more. Oh my gosh. Well, we're not going to decimal. Oh.
That'd be 1/4.
It'd be half of that and be 1/4. Yep, 1/4 radical 3. Or you can either write it this way, or you can just write it radical 3 over 4, right? Okay, that's same as radical 3 over 4. Okay? A lot of times, we get so used to the calculator, but then it's like, okay, this is so much easier if you just do it in radical. Okay? You can convert it if you want to. I'll take the answers either way, but I think you're better off if you get used to working with those radicals, because you're going to have to work with them when you get to the higher level math. Okay? Okay, that should get you started.